In the second half of 12.3, we're going to combine what we learned earlier in the chapter with what we learned in the first half of the lesson. So sketch each angle. That's the initial and the terminal side. So the initial side is always the positive x-axis, and if it's positive, you rotate counterclockwise. So I've gone 90, I need to go 65 more. Okay, now to find the reference angle, that is what we learned in the first half of the lesson. So that involves drawing a triangle. Remember the bow tie rule. So we know 155 is in quadrant 2. So using the bow tie rule, the triangle has to use the negative x-axis. Alright, so then you put theta near the origin. And the reference angle is just how big is theta. So if this was 155, then theta has to be the angle that takes it to 180. So in this case, and this is not always how you're going to do it, in this case it's going to be 180 minus 155. And this, again, this is only true when the angle is in quadrant 2. So the reference angle is 25 degrees. Okay, for number 8, start with the initial side. Rotate counterclockwise. This is 180. I go 50 more. So I sketch the angle. Now I draw the triangle using the bow tie rule. So the triangle would be here. So in quadrant 3, notice the triangle is part of the spiral, but in quadrant 2, the triangle kind of closes the spiral or completes the spiral, combines with it. Theta goes near the origin, and now we have to find how big theta is. So we had gone 180, and now for the triangle, that only includes the additional 50 degrees. So in this case, it was 230 minus 180. So in quadrant 3, you take your angle and subtract 180. In quadrant 2, you take 180 and subtract your angle. So you just have to think, how big is theta based on the triangle? Okay, number 9 is in radians. So whenever your angle is in radians, you have to give the reference angle in radians. Initial side is the positive x-axis. So I have trouble thinking in radians, so I'm going to convert this to degrees. And so I don't usually show all the steps. Recall that pi is 180. 180 divided by 3 is 60. 60 times 4 is 240. So I'm going to sketch 240. So 180 and 60 more. Then I draw the triangle. Alright, remember after I had gone 180, I wanted to go 60 more. So that means the reference angle is 60 degrees. Theta's here, but remember, since they gave us the angle in radians, we need to answer in radians. So 60 is a third of 180, which means it's a third of pi. On number 10, we have a negative angle in radians. remembering that pi is 180. So 180 divided by 6 is 30. So I went negative 30 degrees, and I went clockwise because it's negative. Now I draw the triangle using the bow tie rule. So remember that the reference angle always has to be positive. So we went negative 30 degrees. The size of the angle is 30 degrees, which is pi over 6. Okay, and now we're going to use what we've learned this entire chapter to find an exact value of a trig function. Okay, so you start with a rough sketch of the angle. 90, 180, 270, 60 more is 330. Now I draw the triangle. So using theta, we know theta is 30 degrees. So then we know that a 30, 60, 90 triangle has ratios 1, rad 3, and 2. So opposite the 30 is a 1. Opposite the 60 is a rad 3. And the hypotenuse is 2. So if I want to do the tangent of theta, I have to go opposite of the 30. So I know the angle says 330. So why are we using 30? Well, we just learned that's called a reference angle. So it's difficult to visualize a triangle with a 330 degree angle. It's actually impossible. So instead of doing 330 degrees, we use what's called a reference angle, 30 degrees. Okay, so we go across from 30 degrees, opposite over adjacent, then we rationalize. And then the last thing you have to do, think about ASTC. So we are in the C quadrant. That means cosine is positive, which means tan 330 has to be negative. So the final answer is negative rad 3 over 3. So when you're done, try to figure out, is it positive or is it negative? Okay, the other way you could have done this, think about the unit circle. 330 degrees is this point on the unit circle. What are the coordinates there? So notice the x distance is a lot longer. So that would be rad 3 over 2. The y length is shorter. That's 1/2. But in quadrant 4, the y is negative. So now tangent is not the y. It's also not the x. It's y divided by x. So we take negative 1/2. And we divide by rad 3 over 2, or multiply by 2 over rad 3. So we get negative 1 over rad 3, which rationalizes to negative rad 3 over 3. Okay, I'm going to try number 12 without drawing a triangle. I'm just going to use the unit circle. So first thing I have to do is figure out where or how many degrees is that. Alright, so pi is 180. 180 divided by 4 is 45. 45 times 11 is 495. So remember that 495 degrees goes more than one lap around the circle. So if we subtract 360, we get 135 degrees. What are those called? if they end in the same spot, those are called coterminal. So we know this is the middle right here, and then we just want the x coordinate there. Remember, all middle spots use rad 2 over 2. So the coordinates right there are negative rad 2 over 2, because the x is negative in quadrant 2, and then positive rad 2 over 2, because the y is positive in quadrant 2. And cosine is the x coordinate, so cosine is negative rad 2 over 2. Okay, we have one in quadrant 1. You know that it's going to be positive because all 6 of them are positive. 30 degrees is right here. What are the coordinates there? That's positive rad 3 over 2 and 1/2. Alright, so tangent is y divided by x. So cotangent, being the reciprocal, is x divided by y. So we take x. How do we divide by 1/2? We multiply by 2. These cross out. So cotangent at 30 degrees is rad 3. So again, if you want to do a triangle, which will take longer, but it's easier to visualize, draw the triangle. You know that this is 30 degrees. And you know the ratio, so across from the 30 is a 1. This is a rad 3. This is a 2. And instead of doing opposite over adjacent for tangent, you do adjacent over opposite, and you'll get the same answer. It just takes longer. Okay, cosecant for 5 pi over 4. Pi is 180. 180 divided by 4 is 45. 45 times 5 is 225. So we want to be right here. Middle spots always use rad 2 over 2. In quadrant 3, both of those have to be negative. Both negative. So cosecant is the reciprocal of sine. Sine is y, so we need to take the y coordinate and flip it upside down. Negative 2 divided by rad 2 is negative rad 2. Okay, for number 15, we have a negative 195 degree angle of rotation from standard position. So we know we're going to sketch that angle from standard position. So that angle starts at the initial side, rotates clockwise. So from negative 180 you go 15 more. Now I'm going to draw the triangle. Alright, what other information are we given? We know that the arm that is rotating is 72 feet long. So I'm going to put that on that side because that's the side that's rotating. We know that the axis, so is that the x or the y? Well, the x-axis doesn't have a height, so that has to be y. So this length here is 88. And we want to know the total height. So we're going to be adding this height y to 88. Okay, so what is the reference angle? If I went negative 195, then this reference angle in here has to be 15 degrees. So redrawing that triangle, I have a 15 down here, a y here, and a 72 on the hypotenuse. So it looks like from 15 degrees, we want opposite, we have hypotenuse, so we want to use sine. Sine 15 equals opposite over hypotenuse so this equals 18.6. Now we add 88 to that, and we get 106.6. And the units are in feet. Okay, that's it for this lesson.